Alright, thanks for watching, and today I would like to cover a beautiful problem that combines both algebra and geometry. Namely, suppose you have three real numbers a, b, and c such that a squared plus b squared plus c squared is ab plus bc plus ac, show in fact that a, b, and c must be equal. And there's a nice geometric interpretation to this, namely, suppose you have a triangle with sides a, b, and c such that this identity is satisfied, then in fact this triangle must be equilateral. How cool this is! And what I like even more about this is the method of proof. So let's quickly derive this. And in order to do this, all you need to do, surprisingly, is to multiply both sides by 2. So you get 2a squared plus 2b squared plus 2c squared equals 2ab plus 2bc plus 2ac. And what we would like to do is put everything on the left-hand side. Not only that, let's write this 2a squared as a squared plus a squared. So what we get is a squared plus a squared plus b squared plus b squared plus c squared plus c squared minus 2ab minus 2bc minus 2ac equals 0. Now it turns out, and that's the beauty of this, all this is just a bunch of sums of squares. Because what do we have? We have a squared plus b squared minus 2ab. That's just a minus b squared. On the other hand, a squared plus c squared minus 2ac, that is a minus c squared. And last but not least, b squared plus c squared minus 2bc, that is b minus c squared, equals 0. And therefore, what do we have? We have the sum of three squares is equal to 0, but because they're all real numbers, all of them are non-negative, and the only way they could be 0 is if each number inside the square is 0. So what we get is a minus b equals 0, a minus c equals 0, and b minus c equals 0. But the only way that can happen is if a equals b equals c. And we're done.